Hello ChemStars. Today we're talking about calculation of moles for solutions. Basically, there are two ways we can calculate for the number of moles. Number one is we can calculate for the number of moles for solutions whose concentration is given. Number two, when the concentration of the solution that we are asked to calculate the number of moles is not given, then we can calculate it from another solution whose concentration is known. And that kind of solution is called a standard solution. A standard solution is a solution with a known concentration. Assuming they asked you to find the number of moles for sodium hydroxide, whereas they did not give you the concentration, they have to give you another solution, probably an acid that is meant to react with the sodium hydroxide, which is a base, so that from the concentration of the acid, which is not the standard solution, you can go ahead and calculate for the concentration of the sodium hydroxide. Then you can now go ahead and calculate for the number of moles. Mathematically, number of mole is the concentration in mole per dm cube times volume in dm cube. Why do we say that it is concentration in mole per dm cube? This is because the number of moles must be calculated from a solution of known concentration, and that concentration is usually measured in mole per dm cube. Are you getting me? Good. Now let's go over and solve the questions. It will help you to understand it better. Examples for question number 1. Calculate the number of moles present in 200 cm cube of 0.025 mole per dm cube of HCl, hydrochloric acid. Is a solution of acid in water. Are you getting me? Now they are asking you to calculate the number of moles in what? 200 cm cube. Remember, the formula says that the volume must be in dm cube. Do not forget, just like when we did the one of ideal gases. Okay, now we have to convert 200 cm cube to what? Dm cube, and we go ahead, substitute the variables and get the word answer. Are you getting me? Just like I usually tell you, make sure that you write down the given variables. It will help you to navigate your way and solve the problems. Now let's go ahead and solve it. Solution for question number 1. Now, what are the given parameters? Calculate the number of moles. We do not know the number of moles. In 200 cm cube, talks about what? Volume. Very good. 200 over what? 1000. I've said it initially that 1 dm cube is equals 1000 cm cube. So for you to change any given value from cm cube to dm cube, you must divide it by what? 1000. Good. So when you divide, you have 0.200 dm cube. Now the concentration is 0.025 mole per dm cube. Very good. You have written down the given variables. What is the next step? Write down the formula for solving this problem. Number of moles is equals concentration. I will not be writing this one in the bracket. I want to manage my space, but it's very, very important that you write it whenever you are given question like this to solve. Okay, times volume. This is equals, what is the concentration on the board? 0.025. What is our volume? 0.200. Are you with your calculator? You should be punching by now. So when you multiply 0.025 times 0.200, we are going to have 0.0050 mole of hydrochloric acid. Beautiful. Now let's go ahead and solve the question number 2. The question says, what is the number of moles of 0.095 mole per dm cube in 250 cm cube of a solution? What is the number of moles? We do not know the number of moles, so let's go ahead and solve it together. Number of mole, our n, we do not know. What is our volume? 250 over 1000. Good. 0.25. I hope you know what you are doing here. Simply take it backward. I've said it initially. I've said it before. When you go anti-clockwise, you are dividing, okay? And when you go clockwise, you are multiplying. Please do not forget. This is 3 zeros. 1, 2, 3. Are you getting me? 0.250. That is it, okay? 0.25 dm³. And what is our concentration? Our concentration is 0.095 mole per dm³. Quickly, number of moles is equals our concentration times volume, which is equals to 0.095 times 0.25. When you press your calculator, we'll be having a number of moles at 0.02375. It's a big number. You can write it in 3 significant figures. So you can say it's equals 0.0238 mole of the word solution. All right. Now, just like I normally tell you, or from the previous lesson, one can simply establish relationship that can help you to solve this without using the formula that is given. Are you getting me? Now, let's go and establish our relationship to solve it alternatively. So, I will solve alternatively for number 1. The question is, calculate the number of moles present in 200 cm³ of 0.025 mole per dm³ of hydrogen was chloride. Now you ask yourself, what is the concentration that is given? 0.025 mole in what? Per dm³. Per means what? 1. That means in 1 dm³ you are having a concentration of 0.025. If you are having a concentration of 0.025 in 1 dm³, what will be the concentration in what? 0.200 dm³. Remember, we have converted this thing already. Do not forget. So alternatively, I can say 1 dm³ is equals 0.025 mole per dm³. Now you ask yourself, if 1 dm³ contains or has a concentration of 0.025 mole, what is the concentration for the volume of what? 0.200 or 0.2 dm³. That is just what they're asking us, okay? Now I will say this one, 0.200 dm³ is equals x mole per dm³. We do not know it, okay? Now, what are we going to do in this case? Good. Cross and multiply. Very good. Now we say 1 times x is equals 0.200 times 0.025. And of course, when you divide through by the coefficient of x, which is 1, okay? So we have our x as 0.200 times 0.025. 0.0050 mole of hydrochloric acid. Beautiful. That is the answer. We have done it alternatively without using the formula. Wow. Now let's go ahead and do that for question number 2. Now the question is, what is the number of mole of 0.095 mole per dm³ in 250 cm³ of a solution? Just like what you do here, we do not know the formula. Assuming we do not know the formula, how are we going to go about it? Should we just write no idea in our booklet? No. Okay? This is the beauty of ChemStars. Okay? Now let's go ahead and solve the question. Number of moles of 0.095 mole per dm³, meaning that in every 1 dm cube, in every 1 liter, there is a concentration of 0.095. That is the grammar. Okay, now they are asking you, what is the number of moles? What is the amount that is in 250? Remember to do your conversion, okay, before solving this. We have done our conversion here, so we are not going to do it again. So I'll simply take this one and write that here. 0.25 is equals to x mole per dm cube. We do our cosine multiplication, so our x equals 0.25 times 0.095. When you press your calculator, are we arriving at the same answer? Yeah, because the figures are already the same, okay? So we have our answer as 0.02375. Like I said, you can write it to 3 significant figure. Your S will become 0.0238 mole of the solution. Beautiful. That is the answer. We have used the formula in the method number 1. Number of moles equals concentration in mole per dm cube times volume in dm cube. And the second one, we solve alternatively by establishing relationship between volume and what? Concentration. Okay? Now, for question number 3, it says 24.80 cm cube of 0.1 mole per dm cube of HCl reacted completely with 25.00 cm cube of sodium triiosocarbonate 4. Calculate the number of moles of the base. I think the first thing to do here is to identify the acid and the base. Okay, now the acid is HCl, right? Good. And the base is what? Na2CO3, sodium triiosocarbonate 4. So this is exactly what I explained earlier. I said that we can calculate the number of moles from a standard solution. That means when the concentration of the solution that we are asked to calculate the number of moles is not given, there has to be another way, which is what? Calculating for the concentration from a standard solution, from another solution that has the concentration given. We can calculate the concentration of the one that we are asked to find the number of moles, and then we can go ahead and calculate the number of moles. Are you getting me? Now, you check the next video. That is where we'll be solving this question. Are you with me? Good. It's time for you to do your part. Please like this video, comment, share, say something nice. And if you're yet to subscribe to this channel, go ahead and subscribe. Tell me that you have done that. I want to come and give you an e-hug. Okay? This is ChemStars with goodness. Here, we make chemistry fun. I'm right there waiting for you in my next video. I will see you there. I'm goodness Ijeoma. Bye.